Okay, good afternoon if you're in the Pacific time zone, everyone, and welcome to the contributor onboarding session, the first contributor onboarding session for Working Group Component Standard. So the purpose of this session is just to kind of provide some basic context and history on why the working group exists and what its goals are, and sort of help introduce people who are interested to what we're doing in the code and answer any questions you have. So we're going to kind of introduce ourselves and then provide a little bit of overview, and then we can kind of pause for questions or deep dive into more technical areas depending on interest. So welcome, everyone. So first off, my name is Mike Toffin. I work for Google. I've worked on Kubernetes for about the past 4 years. All over various areas, but one of the main things I've worked on is the component config standardization work, which is also part of this working group. Lee, you want to go?
Yeah, thanks, Mike. And then my name is Lee Capili. I work with Weaveworks and been helping out with the component standard efforts since about March. Also, do we have Lucas on the call?
Lucas hasn't joined yet, but so in addition to myself and Lee, the other chair, the third chair of Working Group Component Standard is Stefan, or STTTS if you know him in open source. I don't think he's able to join today. And Lucas used to be a chair, but recently stepped down due to time constraints. So he may join the meeting as we go, but he's not able to be here yet. So we don't have that many people on the call, so how about everyone introduce themselves briefly?
Yeah, maybe we can have a Jorge step up and take the next intro.
Sweet. Awesome. Hi, everyone. My name is Jorge Alarcon. I just started contributing to the component standard project a couple of weeks ago, so still getting the hang of things, but really excited to be here, and thank you very much for organizing this.
I see David. Hi, David.
Hi, my name is Dave Greenstein. I work for Coda Global. We just started sort of engaging the open source community and working to participate in the different SIGs, as this is a big part of the technology offerings that we work with daily and have for the last couple of years. So thanks for having us, and we're excited to join and help contribute.
Next person on the list is Adres Ibrahim. Are you able to join?
Yeah, good afternoon, everyone. I'm Idris. I'm from Andela, and we've been using Kubernetes for a couple of years now, and sort of thinking maybe it's time for us to also contribute to the product we've been using for a while. So I decided to join this onboarding session so I can get an idea of how it all comes together. And thank you for having me too.
Thanks so much for joining. Good. We always appreciate when people who've had real experience with operating the software then want to come contribute. There's so much help that's needed from people who are actual end users, and so it's a very valuable area of experience. Thanks. So Jorge already introduced himself. Thanks. Matt, you're on the call.
Hey, yeah.
Hey, hi, Matt.
How's it going? So yeah, I work at Beatport. My name is Matt. I'm a fellow. I used to be a colleague of Lee, actually, over here at Beatport, and we do a lot of stuff with Kubernetes over here. So I'm just I'm trying to get into contributing as well, and I've been kind of talking with Lee about it lately, and trying to find my way into open source Kubernetes. So yeah, I'm hoping to kind of make it in and start contributing myself. Yeah, looking forward to it. I'm out in Denver too, in case anybody's wondering.
And Ajima, I don't know if you're able to speak up.
Yeah, my apologies. I'm at work right now and it's not quite convenient, but my name is Olga. I've been following the Kubernetes space for a while and I was looking to get involved and I felt this would probably be something I could do and see how it goes. Thanks for having me.
Yeah, thanks for making the time. I know it's not easy. We all got work, but cool. Alex, also you're able to join. Thanks for making time for this. You might not be able to. Yeah, there you go.
Yeah, hey. Yeah, I'm Alex. I am working for an ISP in Germany, and we're trying to integrate Kubernetes with our OpenStack cloud. So I'm working on this, and I've been trying to kind of like get started contributing with Kubernetes for a while. Mostly doing like some Golang issues and got a bit bored of it. So I'm looking for like a bigger kind of community or like working group where I can contribute to. So yeah, happy to get to know you guys, and hopefully I can contribute some stuff.
Cool. So is that the list?
We also have Sebastian and Denise. Yeah. Sebastian, are you on? Oh yeah. Hey. Cool.
Hello. Hello. I'm just muted. I've been interested in the subject for a while and not sure how I can contribute, but I'm hoping to join this call and find out more.
Cool. All right, and Denise?
Hi, I'm an undergraduate student. I just completed my college from India. I'm right now working as a shadow for Docs release team for 1.16 release. So I'm very new to this Kubernetes community. I'm just finding ways to start contributing and then getting started with the community. Thanks for having me.
Thank you. Cool.
Absolutely. Yeah.
We've got a number of people who are kind of interested, maybe in learning more, maybe in contributing. We've got some, I think, interesting things to talk about today. Recognizing that most of the people here are kind of new to the space. If anything is kind of going over your head, please just speak up and let us know. We can answer more questions. That's what this session's for, is helping you get started and learn. So I'm going to jump into some of the context and history behind the working group, and then once I'm through that, we'll pause for questions and we can branch out depending on interest. So just to start, we have a couple definitions here in the notes. When we talk about components in Kubernetes, there can be different things that we're talking about. In general, a component is just like a unit of some piece of the system. So like it could be an ongoing process or a tool. The pieces we often talk about when we talk about a core component are the things that are really required to run your cluster and the things that come with your cluster. So think like the kubelet, which is running on the node, or kubeproxy, which is running on the node, or the API server that houses all the Kubernetes APIs, or the controller manager that contains all of the standard controllers that come with the Kubernetes cluster. And right now, that's kind of the main focus of the working group. However, there are a number of other components that sit just above this layer or just outside of it. So there's things like integrations with various cloud providers. There's the cluster API project, which is going on outside of Kubernetes core, but is very close to Kubernetes. There's tools like kubeadm that a lot of people use to set up clusters. And so the way that these relate to our working group is they may end up consuming some of the code that we produce. So what's actually the purpose of Working Group Component Standard? There have been a number of different efforts going on in the community to try and standardize various pieces and improve various common parts of the core infrastructure. Some of it is refactoring work. Some of it is we're going to come up with a standard convention that every component's going to follow for something kind of work. And these efforts were kind of all over the place and writing code all over the place. And so the goal of this working group is twofold. One, to create a forum for people to talk about these things and discuss them. because most of that was just happening in random chats, random issues on GitHub, and didn't really have a centralized meeting or place to discuss these things. So that's part one of what the working group is for. And then part two is just to kind of house all the work around moving all of this code that has been spread out everywhere into a common place. And that common place is a repo called component-base for now. As things evolve, that's possibly subject to change, but for now, that's where we're trying to move a lot of this stuff to. And there's links to that repo and also the KEP that kind of kicked off this working group and that repo in open source. And we can dive into those later if people are more interested. And then just to give a brief overview of kind of the areas of standardization that are ongoing right now. One big area, and that's the area that I'm focused on, is management of configuration and flags for all the components. One of the big efforts I've been pushing for the last few years has been to move off of using command line flags and more onto using config files with version schema that are similar to the other Kubernetes API objects, which can simplify the management of those config APIs. We can get more into that later if people are interested. Another area is standardizing the logging subsystem across most Kubernetes components to make sure that we have sort of consistent log messages coming out. And that is mostly housed around kind of the klog project, which is a fork of glog. I think Dims and Vince Pry have been working on that a bunch. And then finally, there's this area around monitoring and debugging endpoints, which are these endpoints that are served by a lot of components. Some components serve all of them, some only serve some of them. There's things like, what's the version of this component? What's the endpoint for health checking? Is there an endpoint I can get the current config off of? Performance monitoring, various metrics. And so there is an item in the charter of the working group to look at that at some point. Nobody's really done it on a consistent basis in our meetings so far. And then second to that is, if somebody wants to get information off these endpoints, how do they auth to that? How do they, can components set up the delegated auth subsystem with the Kubernetes API in order to, extend to support that workflow? So that's just some of the areas. We can add more depending on what people are interested in. If it's an area that is common across all core Kubernetes components, and an area that tends to be non-standard. So again, the purpose of the working group is providing a place where we can discuss how to standardize and improve these common pieces of infrastructure across the core components. So we can pause for questions now.
Thank you. Quick question. When you say like config-based, is it a config on the node, or is it like a config map in Kubernetes?
In terms of the component config stuff?
Yeah.
Yeah, so it can be both, actually. So depending on the component, so you always start with a config file, is the philosophy there. So that file could be on disk, and in fact, all components should support reading that file from disk. However, some components, you might want to configure them via your cluster, and so, for example, the kubelet and kubeproxy both support to varying degrees placing that config file in a config map that it can consume. There's some ongoing work in kubeproxy right now to refactor its API to make it easier to, and more approachable to deal with that, if that makes sense. But the short answer is yes, both. The long answer is even though we support both, there's caveats with each. Does that make sense?
Yeah, absolutely. Thank you.
Just to add a little bit more color to that, if you look at the kubeadm project's use of configs, often kubeadm will start with a list of multiple documents that are in a file that you pass to the tool. kubeadm is used to install a cluster, and part of that is managing the configuration of the components. And Kubernetes will basically distribute versioned copies of the config into the kubesystem namespace in the cluster. And then on join of following nodes, right, it uses it as a distribution mechanism, but then copies down the config from the config maps onto the node for things like the kubelet. And then for kubeproxy, we actually run it as a deployment that hooks up to a config map. So ultimately, the config is being stored in a config map, but then hydrated to disk by Kubernetes in order to configure kubeproxy as a component. So those are just some different examples of how, like, that answer is, it depends, and like, how do you make it happen? Hopefully that's helpful.
Yeah, thank you.
Yeah, so for example, with kubeproxy specifically, you know, assuming it takes a -- config flag pointing to a config file, you might just point that at the path to the file that would be exposed by a config map volume source. So you would sort of build on top of its ability to read a config file.
A lot of that reality of Kubernetes being able to do those things now has been a need since the beginning, but only possible in alpha and beta features as a result of work in the past 3 releases or so. So that's cool.
Right, and the other thing to keep in mind is that the config file APIs to most components are not GA yet. So the kubelets is beta, which means it's relatively stable, but kubeproxies is alpha, and most other components are alpha. So that's just important to keep in mind. If you're playing around with them, keep in mind those stability guarantees. Cool. Do we have any other questions? Any areas of interest people want to dive into?
We can get more into this later, but Jorge mentioned in the Zoom group chat about Lucas's sample config repo, which is a technical example of how config can be made to read a Kubernetes API from disk. So.
Oh, cool. Yeah.
This is licensed under Lucas's personal license, but I'm about to release code to the add-on operators repository today that relicenses this with permission to APL2.
Oh, sweet.
So it's just going to be for some that we're doing in that SIG or that project. But, thanks for bringing that up, Jorge. It's super helpful.
Yeah, that's great. Yeah, I mean, so if people are interested, I can keep talking about component config just to fill time. And then anyone can feel free to interrupt me and ask other questions that are totally unrelated if you come up with something.
Yeah, this is definitely the lowest order complexity thing that we have right now, in that working in component config and making it consumable by people who want to write components, and just having documentation about how to do this stuff. And, I also mentioned like some code generation. Mike, if you want to open up and like kind of give the overview, I could then show some code and demonstrate a problem.
Sure, and to piggyback on what Lee said, there's a lot of work to be done in this area around just migrating flags that are exposed by components into the config APIs. That is just sort of an ongoing process, and there's just lots and lots of parameters that need to be moved. And that's a great way for somebody to get started because it's relatively simple to take a flag and then add a field for it in the config structure. And then there's a few other things you have to do to set it up, but that's just ongoing work that I haven't had a lot of time to do, and Lee hasn't had a lot of time to do. And so if you're just trying to get started, that's a really big help because it directly moves this work forward, but it doesn't take a lot of effort to do. It's just sort of a time thing. And so if people are interested in that, feel free to ping me on Slack or ping the working group chat on Slack, and we can help you get started. So I'm going to jump in. Oh, did someone have a question?
Just a quick one. Is there some sort of like standardized API for all components, or like any parts all components have in common, or is it like every component kind of has its own config API?
Yeah, so every component has typically its own set of parameters. Within that, there are some common areas, and that is part of what we'd like to standardize, to have at least some sort of shared substructures within the configuration APIs. However, many parameters are not in common between components. And so the thing we're trying to standardize is really the style and the API conventions across like components to make those APIs feel consistent, even if you're setting different parameters.
If you've never kind of gotten into the weeds of API machinery, Lucas's KubeCon talk that Jorge linked in the chat, and I believe he added it to the document somewhere as well. Yeah, under resources. Lucas explains, how a Kubernetes API is assembled from the code and from code generation at a high level, and then kind of talks about that lack of shared structures and some suggested areas where we would like to work to unify the way that components are configured to be exactly what you were asking about, Alex. So yeah, we're not there yet, but we would like to be there. And that's totally in scope.
Okay.
Yeah, so I'm going to jump into the second link here. This is a doc I wrote a couple of years ago about, so this was after we prototyped a lot of things in the kubelet and gotten the kubelet's component config API to a v1 beta 1 state. I wrote this doc to kind of capture the background and ideas around that philosophy. And so we can go through this a little bit. The main motivations behind component config were that at the beginning of Kubernetes, every component was just configured with this gigantic set of command line flags. And there are various problems with that. One of the biggest problems is that these APIs are not, or talking about command line flags as an API, these APIs are not particularly easy to version. And we like versioned APIs, and we're very used to the idea of API versioning in Kubernetes for the objects that live in the Kubernetes API server. So this was sort of a perennial pain for us across upgrades, where maybe deprecation policies weren't respected because people didn't understand that there was some policy around how to manage flags. Maybe API reviews weren't happening around the addition of flags. Maybe there's some defaults changing when there shouldn't be. And it was just difficult to manage flags, but we knew how to manage APIs for Kubernetes. And so the general idea was, well, why don't we try and do something more similar to the Kubernetes APIs? And that coupled with the fact that config files are becoming a more popular way to configure utilities in Unix systems these days anyway, as opposed to flags, there might be something there. And so we spent a lot of time thinking about this and building out a philosophy on top of it. And that philosophy is in many ways summarized as use a config file with a version schema, because it's easier to manage. And there's many other reasons in this doc that that's the case. But that's the general idea, is your config APIs should be versioned. And then we also like working with files. And then once you...
Sorry, just to add, config changes are becoming an increasingly popular way to take down the internet. So
yes.
Yeah.
Yep. Indeed. So there's two things here. One, which is sort of what I just talked about, is standardize the conventions and approach to APIs for configuration for all core cluster components. And then The second thing is once you've done that, you can build on top of it with some of these dynamic deployment mechanisms that Kubernetes enables. So one we've already talked about is using a config map to configure like a deployment or a daemon set like kubeproxy. You could just stick its config file. Now there's some caveats, but you could, in theory, just stick its config file in a config map, expose it as a config map volume source to kubeproxy, and then just configure the path to that source on the command line. Of course, there's some caveats around how to properly do progressive rollouts and how to refactor and redesign kubeproxy's API so that a single object can be rolled out across multiple kubeproxies rather than needing another object for every single kubeproxy instance in the cluster, but that's the general idea. So does that make sense to everyone in general? I don't want to go really too deep because there's stuff you can rat hole on infinitely.
No, conceptually it all makes sense.
Cool. And if people are more interested in working on this area, again, feel free to ping me. I can help you get started. So then within that kind of component config area, we have a few different ongoing projects that most of these kind of get into the weeds of it. But the main one that is great for new contributors to help with is this last bullet, which is migrations. Again, if you want to help with that, ping me. And then we have a number of other things. So I'll start with this legacy flag one, and I'll just kind of go through the list. So one of the difficult things with doing an incremental migration of flags to the config APIs is that due to our existing deprecation policies, you need to maintain backwards compatibility with that old command line API for like 2 releases. And when you try to do this seamlessly, there's all sorts of edge cases that show up because what you're effectively doing is giving command line flags precedence over the config file. And the way that flags worked across most Kubernetes components and in most Go applications, this sort of require you to reparse the command line in order to reapply the flags over a config file once you've run it in. So you have this kind of goofy chicken egg problem where you have to read the command line to know where the config file is, and then you have to read the config file, and then in order to enforce that precedence, you have to bring reapply those flag values onto your internal state once you've read that config file. And so the way that we did this in the kubelet was we reparsed the command line, which led to all sorts of edge cases around knowing, because of the way the flag library worked, you had to reparse the whole command line, but you didn't necessarily want values from flags unrelated to the config to be reparsed because some of those parsers had side effects. And so there's all kinds of crazy logic in the kubelet right now to shim out flags that shouldn't be parsed and deal with flags from third-party libraries to protect state outside of the config. And it's really, really complicated, and nobody else wanted to copy it for really good reasons once we built that out. And so this legacy flag library is designed to replace pflag. It's a wrapper around pflag that does some additional things. Namely, it reads all the values off the command line into a scratch space so that once you've read the command line, you don't ever have to read it again. And it's very convenient to apply those values to arbitrary objects after that point. So we're hoping that this can remove a lot of the complexity of the existing implementation in the kubelet and can also be applied to the rest of the components. So Jorge has actually been working on prototyping that in kubeproxy, and the link to that is in the bullets here. So that's one sort of in the weeds deep area of work, but that's kind of important to moving that work forward in other components because sort of everyone's in this situation of needing to do this incremental migration, and everyone's going to need to maintain backwards compatibility due to the deprecation policy. And it's without something like this, it's very complicated to do that. So that's one area of work. There's
Other
also
components are in bad need of that as well. So
yes, so people who are interested in prototyping kind of the future of component config and other components, or even if somebody wants to give the kubelet, a shot, which is probably the hardest possible one to do it in, but if someone's very ambitious, I'd be happy to help with that. So that's one area. The next item on the list is all the work going on around improvements to the encoders and decoders. So Lee, if you want to talk about that, because I think you've been more involved with that.
Yeah, this one's kind of esoteric. Basically, the encoders and decoders that we have, they're part of the runtime library in Kubernetes. This is vendored by imported by basically everything in all of our repositories, because you need encoders and decoders to work with the API groups in your schemes. And this is like how objects basically go from transport back into a memory struct in Golang, right? Or going from a memory struct into something that can be transmitted over gRPC to etcd. And so these things have to be very performant, and they have a few shortcuts currently. So one thing that's a pain that we've had in kubeadm, which has been kind of the pioneer for config, is that people will write their config, but they won't use a capital letter where it should be. And our current encoders, they just drop unknown fields, or they don't care if they're duplicate fields, and decoders. And that can be a problem. So the strict encoder work strict decoder work has been plumbing through our kind of stack of abstractions to be able to, at the very top of the abstraction, which is the codec factory, to say, hey, runtime, please don't let me do things like duplicate fields, and please error out when I have the wrong capitalization, that kind of thing. So that once that plumbing is there, then we can have our component config abstractions be using strict decoders, right? And there are some other, the pretty stuff is in there because it was previously an option, but we're now pulling it out into an options struct. I have some patches that are up there. Once that's done, then we can move on to actually testing the APIs for canonical conformance. So because we generate all of our APIs from code, there's a rather medium size amount of code that you need to write in order to declare your types and your scheme and your API groups and your preferred version. And with a component config, you have to do several versions of your API. And writing all of that code is currently rather manual, and you can do it wrong. What I mean by doing it wrong is you can do it in a way that doesn't follow the Kubernetes API and style conventions. And so the follow-up to the strict decoders is to write a test suite that makes sure that everything in your component is assembled in a way that you expect, with room for exceptions and things like that. But so there's an interesting series of patches that we've had open in a work in progress state for since March. This is a particularly strange area of Kubernetes to be contributing in, and I would be happy to walk anybody through these patches, because getting knowledge about the runtime library I've found is a lot of just reading code and experimenting. This is an area where if you would like to get context, I'd be very happy to help, or even just walk you through a patch so that you can learn more about how things are assembled. But ultimately, at the end of the road of these decoders and test suites is the foundation for making it easy to have a UX where people can generate their component in something like Kube Builder. So currently Kube Builder can generate APIs for custom resources, like CRDs and operators and that kind of thing. And I was chatting with the Kube Builder folks last week, and we think that having Kube Builder be able to generate components that have component config and legacy flag would be quite interesting. So if you're interested in doing code generation, then that is an area that we're trying to work toward. And the decoders and test suites are part of that.
And for those who aren't aware, Kube Builder is a kind of like a tool for getting a project started quickly. So it'll spit out a bunch of boilerplate code, depending on whether you're trying to build a Kubernetes controller or a webhook or maybe some other things. It's kind of like line and gen if you write Clojure.
I can actually demonstrate the issue here if I'm able to. Well, I'd have to take screen sharing over.
We can maybe do that in a minute. Let's get through the rest.
Yeah.
And then...
Matt's comment here is that the abstractions about the types is like really difficult to work with in kubectl. And I can't say from empirical experience about kubectl, but I can tell you that it's really difficult to work with types in Kubernetes. So
yes. Everything is still very low level in a lot of the tooling. And I think that's what a lot of the efforts are around, is how do we lift that to a higher level without losing the fidelity that's actually important to people.
I have a question too.
Sure.
When you're explaining the encoder and decoder part, I didn't really catch the context you gave with how it works with multi-doc support.
Yeah, the multi-doc support thing is an abstraction that we would like. That's kind of what Mike was saying with like going to the higher order, like easier to use things. In kubeadm, we have multi-doc implementation where you can pass a single kubeadm config file with many different API types, right? So you can have a kubelet configuration, a join configuration, cluster configuration, and a kube proxy configuration, all in the same file on disk. Then kubeadm has the multi-doc parser that will split it up, read the types, figure out what they're supposed to be, and then pass those to the proper code paths. And we would like to pull that out into component base, or have a conversation about whether or not we should be doing multi-doc, right? Which maybe we shouldn't be. So
maybe it's
yeah.
very convenient though.
Did I answer your question, Idris?
Yeah, you did. Thank you.
Okay. Yeah.
Cool. So then the next item on this list, so we're going to start really getting in the weeds in the next two. But so even though we're moving to APIs that are at the root, these version config schemas, there's still a desire from a lot of people to be able to override certain parameters on the command line. That's mainly from a UX perspective, because in Kubernetes, for example, in a pod spec, when you can specify a command for a container very easily, but it's considerably more difficult to write a file. You either have to use a config map and use config map volume source, or you have to use an init container. And especially if you're just trying to override a single parameter or a few parameters that would be set in that file, then you're in the business of using sed on the file or doing some other substitution or some other editing at runtime. And it can quickly get very complicated. So Lubomir, who goes by Neolit123 on GitHub, wrote up a proposal for different ways to do that overriding. And sort of the leading piece is to use JSON patch and offer an option to do that. So this document is currently in review. We're having a lot of back and forth on it. If people are interested in kind of that specific piece, now would be a good time to jump into the comments. But again, that's sort of a more advanced area. And then the other item here is Ross's proposal to, or rather tracking of what are the final things we have to do to be able to graduate kubeproxy's component config API to beta. And so he has a KEP that is open for this. And one of the major areas of this KEP is solving two of the sort of unsolved problems in the component config space, one of which is how to deal with platform-specific configuration. So conventions around writing APIs so that if you have some parameters that only make sense on Linux and other parameters that only make sense on Windows, for example, what's kind of our convention for representing that in a structure? And then the other problem is how to deal with instance-specific configuration. So there's certain things like IP addresses that are only ever specific to a single instance of a component running somewhere in the cluster. And so you can't share that configuration between multiple instances. And this is a challenge if you were to just take like a basic config file that say had an IP address field in it and try to share that state across many components in the cluster, because the config would only be right for one component. So for example, if you have a daemon set that's configured with pointing to one config map, it's possible to do a progressive rollout where you turn up new containers that are pointing to a new config map and turn down the old ones. But once you reach a steady state with that model, it's impossible at present to easily configure a field that only applies to one of those instances via the config file. It's easier to do that via the command line. Maybe you run a init container, maybe you do some shell on the command line when you start it up, some substitution, but it's much harder to do into a raw file. And so part of this proposal is figuring out, can we split it up and have multiple files, and what do we do around that? So this is kind of the place to dig into those two issues if you're interested in that. And then finally, we're back to the migrations. So I'll open again for questions, and then Lee, if you wanted to switch to your...
Just showing the code for an API, basically.
Cool. So questions, if anyone has questions on those.
So what's the current state of, sorry.
That's all right, go ahead.
All right. What's the current state of like the migrations? Is there some overview of what components require what amount of love in this area, or?
We probably need to have better tracking of that. We've had various attempts in the past. Like a year ago, I created 100-some GitHub issues for tracking the kubelet migrations. So if you search for like kubelet flags and GitHub issues, you'll probably find the auto-created issues. A lot of them have been closed by robots at this point because people weren't working on them. And then we also have sort of an overall tracking issue for the working group, but that's also somewhat out of date. So the short answer is like, no, there's not really a good way, but if you're interested in working on that, I can help you.
All right, cool.
I was basically about to start asking the same thing. Like, is there a list of issue numbers or stuff like that that we can start reading up on? But you just answered that. Great minds and all that. Thank you, guys.
Yep, and if you are familiar with the Kubernetes code, at least to a cursory degree, most components have like a command like cmd directory, and then somewhere under that directory there'll be a file called options.go, and that's usually where the flags are registered. And in components that are in the process of adopting component config, those flags will be configured to write their values into the component config structure. So if you find that file, you can usually trace from there, you know, which flags have been migrated and which haven't.
I'm going to take a note of that.
And that's specifically true for the kubelet. I think kubeproxy has a more complicated pattern that it initially used for its flags and configuration. So things might be a little bit different there. Then the same goes for like kube controller manager. I think uses a similar pattern to kubeproxy. And I can go find some examples of moving these for the kubelet and add it to this doc as well. And that'll probably be the most helpful to people who are interested. You can pretty much see exactly how much work is remaining just by looking at that file. So I will add that after the meeting.
Lee, one more question while you are adding this comment. So the component config structure, would that be in the same file in options.go, or would it be located somewhere else?
Yeah,
I will show you what that looks like.
Okay.
It's
Cool.
typically located somewhere else. I'm going to stop sharing here, Lee, so that you can share. It's typically located somewhere else. It's defined according to the same sort of machinery and conventions that Kubernetes APIs are defined as. So you end up creating an API group for your component, and then you sort of follow the existing Kubernetes API conventions, which include a basic directory hierarchy under that directory that you're creating the API group in. So yeah, there are many examples across the Kubernetes code base. Lee, if you want to show maybe one of them. And again, if you're having trouble finding anything, feel free to ping us after the meeting.
Couldn't figure out how to unmute myself. So can everyone see? You can see, right?
Yeah.
Cool. This is exactly what Mike was talking about, right? So here we have a command line tool, right, called installer. And in the main, it parses flags and reads a config from some other places. So that read config, what's happening in there? Well, it is importing a bunch of libraries from a similar location. So this is the directory that I'm in right now, except in command. Under package APIs, this is kind of like a canonical path. We have this config directory, right? So I have a config API inside of my packages. And then we're doing a bunch of machinery here that needs to be standardized. So that's the command line tool invoking reading a config. So to your question, Alex, I think you were asking about where that structure is. This is where our config API is, right here, this folder. And there's a scheme here, right? So the scheme is what holds all of the type mappings for the, basically the Golang definitions of what the JSON and YAML equivalents are. And gRPC if you are doing API server API. But so a scheme, you can see it's importing config and then config v1 alpha 1. So this is what's referred to as an internal type, and then this is an external type. The internal type is the parent. The internal type is what the component wants to get the config to in memory. So we would typically read an external type from disk and then serialize it into an internal type. Or sorry, deserialize it.
So it gets deserialized into the external structure and then converted via the conversion machinery into the internal type. And the reason that happens is the way that conversions between different external versions work today is that there's a bunch of code gen that generates these automated conversions that first go from an external type into the internal type and then can go back from the internal type into another external type, another version of the external type.
Yes. So you can see here, right, the basic API, if we didn't have any external version, is just config, and then you have types and register.go. So the register.go is used to basically add to the scheme, which is in scheme. And this is basically the meat of our API right here. Right, this is very simple. I just have an add-on installer configuration struct. There is a bunch of these other files because we have to tell Kubernetes about like what the domain of the API is, right? And what the preferred version is and that kind of thing, and how to add it to the type registry, which is a scheme. And we need to do that same thing then for the internal version, right? So these ZZ files right here, which are about conversion.
Sorry to interrupt. Can you go back to the register.go file?
Yeah.
Is this typically you should register like a subdomain at config.kh.io. So like the API group for your component will be like foo.config.kh.io. I don't have state on this, so I'm not going to like critique it, but just FYI to everyone who's listening, when you do this for another Kubernetes component, so like the kubelets is kubelet.config.kh.io.
Yeah, this would be probably add-ons, right? Yeah.
Right.
Thanks for catching that. Yep. Yeah. I think, yeah, and then I would have to. So here's an example, right, where it's like I had to write all this code. And this is where it would be great to have a test suite that catches the fact that the group name, like in the different versions, would not be conformant to the spec, or maybe I even configured them in the wrong group, right? Like I put one in one group and one in the other.
And validation for us developers to help us as well.
Yes, but you write all of these files kind of by hand. And you have to put them in the proper packages, and you need to annotate them with these code generating annotations. And it's just quite difficult. So KubeBuilder can help you do a lot of this stuff, but it can't do it for a component config style API, which has an internal type.
That said, most of the components that are migrating to component config have already done this step. So you really have to do this yourself if you're just getting started on an existing core component.
Mm-hmm.
If you do end up having to do it, a lot of times you can kind of copy paste
and then grep, grep instead.
Well, you delete most of it except for the one of the objects in the header, and then do what you want.
But basically, yeah, to Mike's point about how you don't have to do this, the time you have to do this is when you want to create a new component. So I mean that's a higher order need for sure than having the test suite that ensures that our APIs are correct, or having the strict decoding which ensures that people can use their config files in the same manner without crazy errors, or no errors. Yeah.
Lee, do you by any chance have the Kubernetes repo open in your editor?
I can do that. Why?
We can show the kubelet stuff really quick.
Yeah.
So yeah, just open the
Kubernetes.
Yep.
Yep.
And then if you head into command kubelet app options.go.
App options test. It's like options.
It's just options.go. It's options/options.go.
Yeah, here we go.
This is where the kubelets flags are registered. There's two objects at play here. One is kubelet flags, which are things that are currently just flags and not config, and the other one is kubelet configuration, which comes out of the directory that defines that component config type, which is similar to what we just showed you.
This import right here.
Yes.
Should be it. Yep.
That's it. And then,
so if I went to that, right, then I'm now in a Go doc, right? This is an imported library from a different repo.
That's the kubelets component config API. Yeah. And so then if you scroll down that options file.
Sorry, I have to open it again. I forgot to like.
Oh yeah, it does that preview thing. Yeah, double click the tab to keep it open.
There we go.
Then if you scroll down to keep going, validation. I think it's like way at the bottom. Here we go. So here you'll start to see there are two functions in here. One adds the config flags, one adds the flags that are just flags. And it's just a long list of flag registrations. So if you look at this file, you can see which parameters have been moved and which haven't. Some of the parameters can't be moved yet because they're either instance-specific or platform-specific config, and we haven't figured out how to handle that yet, and that's kind of what Ross is working on in keyproxy right now. But a lot of them can be moved and just haven't. So, take a look at the parameter. If it seems like something that should be reasonably shareable across multiple instances or multiple nodes, then it probably makes sense to move it.
This is an example of where we could probably have a shared struct with the TLS config.
That's totally an example where there should be a shared type. That's
yeah. Do you actually? Can you help identify in this list, Mike, of something that's not moved over?
So the list you're looking at right now is everything that has been moved.
Yeah. So then this is
yes. So
add flags.
Start with f dot are the flags. And so this function is registering everything that hasn't been moved.
Yeah. So like cert directory, that's probably a good one.
Possibly.
That could be instance config, but bunch of experimental
maybe
stuff.
have an argument about it, but it's something that can move. And then there's also a conversation that usually happens around, well, is this actually a flag we even want to keep?
Yep.
And on one hand, that might slow things down a little bit if you're just trying to move it, but on the other, especially if you're new, you'll probably learn a lot about Kubernetes by participating in that discussion about whether or not it should be deprecated, because you'll get a lot of the context and history of why it existed in the first place. So that can actually be a good way to get some experience.
If true, exit after spawning pods from static pod files. That is a fascinating flag.
Yeah, that's like there for people who are just want to like run some stuff and they're doing a one-off thing. I'm not sure if anyone uses that anymore, but
I mean, it's a cool flag.
No guarantees on how supported that is, though.
Yeah. Really crashed for testing.
That's
a good one.
Yeah.
And,
sorry, by the way. Hi. I totally messed up the time. So I joined now and thought it would be from now onwards an hour. Do we have a hard stop in 1 minute?
I mean, some people may be able to, or may have to drop, but I don't have a hard stop.
I have to get going, and I'm recording, so we're probably going to cut it now. But we can schedule another session maybe in a few weeks for everyone to kind of follow up on what we talked about here, and maybe even bring in some other new people.
Yeah. How did we have much of our agenda left here? We talked about, we didn't get into like Klog.
But we don't really have resources. We need DIMS really to talk about Klog.
And then there's a bunch of future stuff that can be worked on.
We've never talked about that as a group. So if people are interested in any of the words that they see in these notes, please reach out to us and we'll figure out how we can do that. We need help in a lot of areas, so we're really excited that there are people here willing to help or interested, and we'll dedicate time to help you.
Yeah, please join our Slack channel and or the mailing list and post any questions. I'll be monitoring both of those very closely so that we can help you get connected with people who can, get you to your goals. And ultimately, let's all make Kubernetes a little bit of a better place by standardizing this stuff.
Okay. All right. Thanks
so
so
just
much.
want to check to make sure that will you send out the link to the recording to today's participants?
Yeah, so we're gonna add it to the YouTube playlist for Working Group Component Standard. So you should just be able to find it in the typical meetings.
Can I know the Slack channel name? Is it SIG?
WG-Component Standard.
Yeah, just like this.
Okay.
Do we have a link to the playlist here, Mike? We could probably.
I will add it. It should
Yeah.
be there, but it's not. So I will add it.
So,
Yeah, just can you assign that to me?
yes.
Yes.
YouTube playlist. Do. And then I hit this, right, to assign?
Yep, and then just plus mtoffen@google.com.
Yeah.
Do the Google one. Do my Google.
Oh, sorry.
Yeah, I'm not like this. It's
Cool.
sweet. Thanks so much, everyone. This is a pretty great session. Seems like we've got some good interest, and we're excited about that. So again, feel free to reach out to any of us for help getting started, and we're happy to have you. Thank you.
Mm-hmm. Thanks all.
Thanks.
Thank
Thank you.
you.
Appreciate it.
Yeah, if you have questions, just follow up in Slack. So.
Cool.
Thank you.
Bye bye.